In this video, we're going to take a look at 𝗬𝗑, which is a new package and project management tool in the Python ecosystem. And I'm on the documentation just now, and you can see that 𝗬𝗑 is an extremely fast Python package and project manager, and it's been written in Rust. And 𝗬𝗑 was actually created by the same people that created the rough formatter and linter tool in Python, and that's been able to replace a lot of different tools in that space, such as Black and isort and so on. And 𝗬𝗑, on the other hand, is a very fast packaging tool, and you can see it here compared to tools like 𝗏𝗏, PDM, and so on, much faster when it comes to installing the Trio package and its dependencies. So 𝗬𝗑 is a single tool that could potentially replace pip, pip_tools, pipx, and so on in your Python systems and your projects. And if you're using pip, this package here, 𝗬𝗑, can be 10 to 100 times faster when it comes to installing your requirements. Now I've got a link to this page below the video. We're going to take a look at the GitHub page as well. You can see that 𝗬𝗑 has 23,000 stars, quite a lot of stars for a packaging tool in Python. So it's very popular at the moment, and it's a very new tool. We're going to dive in this video, and we're going to create a project using 𝗬𝗑. Now for an overview of the features, let's go back to the documentation. And what we have here is the capability of managing projects. So you can initialize projects, and you can then install packages such as Rough or Django or Pandas and so on into that project. And 𝗬𝗑 will automatically create virtual environments, so it's going to take care of that process for you as well. And it will install the dependencies into that virtual environment automatically. And then once you have that, you can then run your projects using the 𝗬𝗑 run command. And 𝗬𝗑 even has the capability of managing Python versions on your operating system as well, and for the given projects that you're working on. Now, as well as all that, if we go down here to the tool management section, 𝗬𝗑 also executes and installs command line tools that are provided by Python packages. So similar to pipx, if you've used that before. We also have tool management, and if we scroll down even further, as you can see, Python management as well. So I'm going to go to the GitHub page to get started here, and let's scroll down to the installation section. Now, depending on your operating system, you can install 𝗬𝗑 as a standalone installer. So if you're on Mac and Linux, you can use the curl command and grab it from this link here. And if you're on Windows, you can run this command in PowerShell. And you can also install 𝗬𝗑 using pip. So if you run the pip install 𝗬𝗑 command, that's going to install 𝗬𝗑 onto your system Python version. And then you can run that as a command. So what I'm going to do now is go to the terminal here. And I've already installed this. If we run the 𝗬𝗑 command, you can see we get some output here, including the commands that we can run. For example, the 𝗬𝗑 run command, that's going to run a command or a script. And we also have the capability of initializing a new project with the 𝗬𝗑 init command. That will create a new project to which you can then add and remove dependencies. You can generate lock files with the 𝗬𝗑 lock command. And there are many more commands, and we're going to dive into some of these now. Now, one thing to note is that 𝗬𝗑 has no Python dependency, so you can install this separate to Python itself. And that's going to help you avoid the need to manage different Python installations. For example, if you're on a Mac or Linux, you might be running Python, and that's Python version 2.7 or something like that. And you also have a different version for Python 3 or Python 3.10. So all that management of different versions, you can forget about that if you're using 𝗬𝗑. You just need to install it as a standalone package. And then what I'm going to do is just clear the terminal just now. And we're going to look at one of the commands, and that's 𝗬𝗑 python list. Now the list command is going to list out the versions of Python that are installed on your system. And this is quite interesting. So we don't have Python 3.13 installed, but you can see this on the right hand side here, download available. We can actually download that and install it. And we're going to see an example of that later in the video. But we also have the versions that we do have installed. For example, 3.11.3, we have that, and it gives us the location of that Python executable. Now what I'm going to do is just clear the terminal for now. And I'm currently in an empty directory. If we run ls, we've got nothing in this directory. And we're going to run the 𝗬𝗑 init command. And remember, the 𝗬𝗑 init command is going to create a new project. And we can give the project a name. So for this example, I'm just going to give it a name of my project. And I'm going to pass a flag to this, or an option on the command line. And we can actually pass the --python option. And after that, we can specify the version that we want. For example, Python version 3.13. So what we can do here is run this command. And what that's going to do is initialize the project at the given location. So if I now run the ls command and we go into the my project directory that's been created here, if we run ls here, you can see some of the files that have been generated by the 𝗬𝗑 init command. Now I'm going to open this directory using Visual Studio Code, and I've got this open now in VS Code, and we can see the files on the left hand side. So we now have a project, and it's called my project. And the file I'm going to look at first here is the hello.py file. So this is a general file that's just created when you initialize a project. And we can change this later on, and we're going to do that. And importantly, we also have a pyproject.toml file. And you can see some metadata in the pyproject.toml file. So we have what's called a table here called project. And underneath that, we have the name of the project, we have a version number, and we can add descriptions and a link to a README as well. And importantly, we also have these two options at the bottom. Now, the requires Python option is going to determine the minimum version of Python that this project is going to support. You can see here it's greater than or equal to 3.13. And then we have an empty list here at the bottom for the dependencies for the project. Now, 𝗬𝗑 is going to be capable of managing the dependencies as we're about to see. But currently, when you first generate the project, it's going to be an empty array. Now, if you're wondering what pyproject.toml is, I'm going to open this page here. This is a configuration file that's used by packaging tools, and it's also used by tools such as linters and type checkers such as 𝗦𝗍𝗽. So for any project that you create and you distribute online as a third-party package, the chances are in the modern Python ecosystem, you're going to create a pyproject.toml file, and that's going to be a config file for your project. And it's going to tell things, as you can see here in VS Code, such as what dependencies you have and what version of Python the project supports. Now let's say that in this project we're going to create a FastAPI web application, and that's going to connect to a database using 𝗬𝗵𝗽𝗁𝗵, and it's going to use 𝗖𝗵𝗽𝗶𝗴 for database migrations. So what we're going to do is we're going to add some dependencies to this project. So if we go back to the 𝗬𝗑 documentation, let's go to the concept section on the left, and we're going to go to this projects page. So Python projects, they help manage Python applications that span multiple files, and the project metadata, as we've seen, is defined in the pyproject.toml file. Now, if we go to the right-hand side here, there's a section on managing dependencies. So 𝗬𝗑 is capable of adding and updating and also removing dependencies using the CLI. To add a dependency, we need to run the 𝗬𝗑 add command. So let's go back to the terminal here, and let's just do this on VS Code actually. What we're going to do is add the requirements here. So FastAPI is the web framework that we're going to use for this dummy project. And we're going to use 𝗬𝗵𝗽𝗁𝗵 for the database connections. And finally, let's say we wanted to use 𝗖𝗵𝗽𝗃 for migrations. Now, quite a few things are going to happen when we run this command here. First of all, 𝗬𝗑 is automatically going to create a Python virtual environment using the version that's specified here when we ran the 𝗬𝗑 init command. And that's going to appear on the left-hand side in a .venv folder. And 𝗬𝗑 is also going to make sure that the .getignore file contains the .venv folder, so we're not going to push the code from our virtual environment up to GitHub. There's no need to do that, so that's automatically added to getignore. And what's also going to happen when we run this command is if we go back to pyproject.toml, these dependencies that we're adding are going to be automatically added to the dependencies list in this file. And finally, this command is going to generate a 𝗬𝗑.lock file, and that's a lock file that specifies what versions of all of the dependencies and their sub-dependencies are required for the project. So let's run the command 𝗬𝗑 add, and we're going to see this process in effect. It's going to install the requirements, and it's going to create the Python virtual environment. Now you can see to start with, this is actually downloading the version of Python, and that's 3.13. And you can see that it's also installed those packages, and that was very quick for this process. We've installed a version of Python, and we've also downloaded a number of packages, and it was very fast in order to do that. And once you start using 𝗬𝗑, it becomes even faster because it keeps a cache in the background. We're not going to look at that in this video, but what we are going to see is that we have this virtual environment now created. And whenever you run a command with 𝗬𝗑, for example, if we were to use the 𝗬𝗑 run command on the terminal, that's automatically going to use the virtual environment in this directory. So that's been created for us. And if we go to pyproject.toml, you can see here the dependencies for 𝗖𝗵𝗽𝗃, FastAPI, and 𝗂𝗵𝗽. They have been added to that array. And finally, we also have the 𝗬𝗑.lock file. So if we open that, you can see the lock file for the different dependencies in this project, as well as any sub-dependencies for those. For example, FastAPI depends on a number of packages like Pydantic and also Starlet, as well as many others. So they're all going to be present in this lock file. If I search for Pydantic in here, we're going to see that FastAPI itself has these dependencies for Pydantic, Starlet, and typing extensions. And we can see the versions for Pydantic as well in the lock file. Now I'm going to close the lock file for now, and we're going to move on. But I just want to note again how quick that process was and how convenient it is to be able to run one command and have all of that created, for example, the virtual environment, and also to manage the dependencies in this way. So we now have a UV managed environment. I'm going to go to 𝗏𝗏𝗽 and let's convert this to a FastAPI application. So at the top of the file here, we're going to import the FastAPI object, and we can instantiate that here to create an application. And we're going to take this main function here and we're going to create a handler from that. So let's decorate the function with app.get, and the route that we're going to pass here is just the base route here, just the slash, and then we're going to return a response from this handler function. So I'm just going to return a text response. So let's return a piece of text here, and it's just going to say hello from FastAPI. Now we can use the UV run command to actually run the FastAPI server, and we can then go to this route here and we can see the response that we're going to get. But in order to do that with FastAPI, I'm going to install another package. So let's run the UV add command again, and we're going to install the 𝗬𝗏𝗀𝗃 package. So when we run that, you can see that it's installed those packages very quickly. And we can now use the UV run command to actually run the server with the UV environment. So the command at the bottom here, I'm going to make this a little bit bigger so we can see it. It's the UV run command, and then we invoke the 𝗬𝗏𝗀 server, and we pass a path to this app object here. So that's in a file called hello.py, and the object name is app. And we can also pass a port number here, for example, port 8000. And I'm also going to pass the -- reload flag here, and that means that the server is going to reload whenever anything changes. Now it's worth noting before we run this command that we don't have a virtual environment activated on the terminal, but because we're using UV run, it's going to be smart enough to use the virtual environment in this .venv folder that has been created earlier when we ran the UV add command. And once we run that command, you can see that the server is started, the application is ready, and we can go to the browser and we're going to navigate to localhost 8000. So if we go to localhost 8000, you can see we get the response hello from FastAPI, and that's what we added to the handler function. We returned that text here. So that's all working, and we're running all of this using UV. Now what I want to do is just show another command from the UV package, and that's the 𝗬𝗏𝗃 command. So I'm going to stop the server at the moment, and we're going to clear out the terminal. And let's imagine that we've downloaded this project from GitHub. We've got other developers who have created this, and we are new on the team, and we have to install the requirements in the pyproject.toml file. And we also have to create the virtual environment. So what I'm going to do here is remove this from the file system. So I'm going to delete the virtual environment folder. So now that that's gone, and imagine we've inherited this project, what we can do on the command line is run the 𝗬𝗃 command. Now I'm going to make the terminal a little bit bigger here, and we can run 𝗬𝗃 --help. And if we go to the top here for that command, we're going to see what that actually does, and there's quite a lot of options here, so I'm going to keep scrolling up. What this does is it updates the project's environment. Now we want to create an environment when we run this command, so what we're going to do is run 𝗬𝗃, and when we run that, you can see that it's installing all of those packages, and we have the option in VS Code here to actually select this for the workspace folder. I'm going to select that. But the important thing is that it's generated the virtual environment directory again, and it's installed all of those packages. So we have in the lib directory 𝗬𝗵P𝗽𝗶 and all of the other packages that we need for this project. So that's been done, and you can do that using 𝗬𝗃. If we go to the documentation for this command, syncing is going to ensure that all of the project dependencies are installed and they are up to date with the lock file. So the lock file is something that's going to be committed to source control, and then when you pull that project for the first time or you clone it, you can then run 𝗬𝗃 in order to install all of those requirements into your application's environment. And just to demonstrate that this is now working again, we're going to run the 𝗬𝗏𝗀 command again, and we're going to start the server on port 8000. And if we go back to the browser and go to localhost 8000 and refresh that, you can get the same response as before. So that's all working, and we've run the 𝗬𝗃 command in order to actually create the virtual environment and install all of the dependencies so that we can run the project. Now I want to go back to the UV documentation, and now we're going to demonstrate how we can install optional dependencies. So on the left-hand sidebar, we have under the concepts header a section for dependencies. So let's click that, and we're going to this page here. Now in UV, project dependencies are declared across two pyproject.toml tables. So we have project.dependencies, and that's the one we've seen so far, but we also have another one called tool.uv.sources. Now project.dependencies, that's the standards compliant dependency metadata. What we're going to do is look at the right hand side here, and we're going to look at optional dependencies. And this is common in projects that are published as libraries. They can make some features optional to reduce the default dependency tree, in other words, to reduce the number of packages that are required by default. So if you're using something like pandas, for example, you might not need the Excel functionality, but that is there as an extra that you can install, and the same for the plotting functionality in pandas. And the way that this would work is you have your project table in the pyproject.toml file, and the project name here is pandas, but for pandas there are some optional dependencies and they're grouped together. So for example, the plot extras, that will also install matplotlib into the environment, and for Excel we have a variety of dependencies here. So these can be installed if they're required, and these are what's called optional dependencies. Now, in order to actually add an optional dependency, you can use the optional option in the uv add command. So let's imagine that we're adding HTTPX, which is a package for sending requests, but this is an optional part of our application, and we want to give the optional group the name network. And we add the optional flag and the name of that optional group. And that's going to then create a block here called optional dependencies in the pyproject.toml file. And the group's going to be called network. And any packages that are part of that are going to be here in the list. Now, even more common than this is the development dependencies. So let's click that and we're going to look at this. So unlike optional dependencies, these development dependencies are local only, and they're not going to be included in the project requirements when they're published to PyPI. And as such, development dependencies are included under the tool.uv table in the pyproject.toml file. To add a development dependency, you just add the --dev flag when you run the uv add command. So I'm going to copy this command here, and let's go back to the terminal that we have in VS Code. I'm going to stop the server here and clear this terminal, and we're going to paste this in so that we can run this command. Now we're adding rough to the project, so that's going to install rough. And it's also going to add to pyproject.toml this tool.uv table, and you can see the dev dependencies such as rough can be added in this manner. Now, if you think of development dependencies, for example, you might think of things like PyTest. So testing is something that's very important for an application, but it's not actually critical to the functionality of the final application. It's just used in development for the sanity of the developer, essentially. So that's another development dependency you might want to add, and also things such as black and isort and pylint as well. Now, before we move on to scripting with UV, I want to just clear the terminal. And let's say that this project has evolved and we no longer want to use a relational database. So we don't need 𝗖𝗵𝗽𝗁 and we don't need 𝗬𝗵𝗽 in this project. It's very easy to remove these. We can just run the uv remove command, and we pass the packages that we want to remove to that command. So I'm going to pass 𝗬𝗵𝗽 and 𝗖𝗵𝗽. And then when we run that command, you can see that it's uninstalled those packages. So let's clear the terminal. And if we look at pyproject.toml, the dependencies array here only contains FastAPI and 𝗬𝗵𝗽𝗁. Now, one other command I want to run very quickly here is the uv tree command. And that gives us a dependency tree for our project. So for example, we have a project here, it's called My Project, and we can see the dependencies underneath that. We have at the top level FastAPI and 𝗬𝗵𝗽𝗁, and we can also see the dependencies for those packages. So 𝗬𝗵𝗽𝗁 has 2 of them, and then FastAPI has a few such as Pydantic and Starlet, and those in turn have their own sub-dependencies. So we can see the tree in this manner. So that's a very useful command if you want to look at your dependency tree. So let's clear the terminal, and we're going to move on to scripting and how we can run scripts with UV. Now, so far we've seen how to run UV in a project such as this one. And remember, we initialize that using the uv init command. Now, what I'm going to do now is go to this project directory here, and I'm going to open the parent directory so that we can create scripts and environments in the parent directory. So I'm going to do that just now. So I'm now in the parent directory, and we have a project directory here. What we're going to do in the parent directory is add a Python script. So I'm going to create a script here called API request.py, and I'm just going to paste some code into that, and we're going to have a look at this script here. So we import the requests package at the top, and then we have a run method here that's sending a get request, and this is just going to JSON-placeholder.com. We convert the return data from JSON to a Python dictionary, and then we're just going to print that to the terminal. So it's a very simple script, but notice that it does have a dependency to the requests package. Now, in order to run scripts, UV has a command for that, and that's the uv run command. So if we try and run uv run API request.py, you can see we get an exception here. So we have the module not found error, and the problem is there's no module named requests. And that makes sense because when we run the command, we've not specified anything about the dependencies for this script. So UV doesn't know where to find the requests package, but we can actually tell it to use requests with a simple addition to that command. So what I'm going to do is clear the terminal, and let's bring back the command that we did run before If we run 𝗬𝗑run and then pass --with, we can specify any third-party dependencies that we need for this command. So I'm going to pass requests into that option. And then when we run the command, you can see that we get back the response here containing the JSON from this URL here. So basically when we run this command here with the third-party dependencies passed in using the with option, 𝗬𝗑 is then going to install the requests package and it's going to use that for the script. Now basically 𝗬𝗑 is going to look in the directory that you're running the 𝗬𝗑run command, and if it doesn't find that .venv folder, then the command is just going to be run in the environment of whatever Python interpreter is discovered. So that's quite useful to be able to do that, but for your Python scripts that have a lot of dependencies, you might not want to have to pass them in on the command line every time you run the script. Now there's a new metadata format in Python for this, and it's called Inline Script Metadata. Or at least I think it's quite new, but it's something I've been seeing a lot more recently. And this specification defines a metadata format that can be embedded in single-file Python scripts in order to assist launchers, IDEs, and other external tools that might need to interact with those scripts. Now what you do is you basically define a metadata comment block at the top of the file, and what we want to do is look at this on the right hand side is the script type. If we go down here, what happens is that the first type of the metadata block is named script, and this contains metadata such as dependency data and also tool configuration information. So the script metadata might also include dependencies and the requires Python option. And that's exactly what we're going to do just now. So what I'm going to do is look at the example here, and we're going to copy this comment at the top of the file, and I'm going to go back to our API request.py file. So let's minimize the terminal, and at the top here, I'm going to paste this in, and we can bring the import of requests to the line below. Now, if we look at what's in here, we're going to change this up a little bit. So first of all, we're going to use Python 3.13, so we can change requires Python here. And you can see how powerful that is here. You can tell 𝗬𝗑 just by using this comment at the top of the script what versions of Python to use, or what version is the minimum acceptable version. And then we can pass the dependencies as well. So what I'm going to pass in here is just requests. I'm not going to specify anything about the version. And then if we go back to the command line here, I'm going to remove the option that we passed, and that was the with option. Let's just run API request.py, and you can see that comment at the top. It's reading the inline script metadata, and it's able to then go and get that data from the API and display it on the terminal. So now we don't need to pass the dependencies into the command itself. We simply define this inline script metadata at the top of API request.py or whatever Python script you're working with. And 𝗬𝗑 is automatically going to be able to read that, and it's automatically going to install those dependencies when it's running the script. And just to prove that this is working with the inline metadata, if we go back here and remove the comment at the top, so if I delete that and save this, if we try and run that without the metadata, we get the module not found error. So that's working, but I want to show a more convenient way to add this. So rather than memorizing that structure of the comment block for the metadata, 𝗬𝗑 actually provides a convenient way to add inline script metadata to a Python script. So let's clear the terminal, and we're going to run the 𝗬𝗑 add command. But because we're not in a project, we are in a Python script, we're going to add the --script option, and then we can pass the name of the file that we want to add this inline metadata to. And to automatically add the requests module as part of the dependencies, we can just pass that after this option here. So the command is 𝗬𝗑 add --script, and then we pass the name of the script here, and then we can pass any dependencies after that. So that --script flag allows us to automatically generate the comment for the inline metadata, as you can see at the top here. And that's more convenient than having to memorize this format here for the script. And again, once we've added that, we can simply run the command. So 𝗬𝗑 run API request.py, it reads the inline script metadata, and then you can get the response because it's already installed requests based on what's in the metadata. So when you have Python scripts, this is powerful because you don't need to create a single virtual environment for each one of them. You can just add the dependencies as inline script metadata, and then with 𝗬𝗑, you can just read that metadata. It's going to install that automatically when you run the script. And that keeps everything for your script very self-contained within that one file. Now, if you do need to create a virtual environment out with a project, you can run the 𝗬𝗑venv command, and that's going to create a virtual environment in the local directory. And you can see that here, it won't have anything installed by default, but you can activate that the normal way using the source command on Mac and on Linux. And once you've activated the environment, you can then run commands. So if you need to create it manually for whatever reason, you can do that using the 𝗵 venv command. But remember, when you initialize a project with 𝗵, whenever you install a dependency or sync the project to the pyproject.toml requirements, what's going to happen then is you're going to automatically create the virtual environment with 𝗵, so you don't need to worry about that manually. So I think that's all I want to show for this video. You can actually do much more with 𝗵. For example, there is the concept of tool management that you can do with 𝗵 as well. So I'm going to go to the documentation. Now on the left-hand side, we have workspaces and tools. I want to take a very quick look at these. So tools are Python packages that provide command line interfaces. An example of that might be something like rough or black. And 𝗵 provides a dedicated interface for interacting with tools. If you'd like to see another video on this, let me know in the comments. And we also have workspaces as well. And this is inspired by the cargo concept from the Rust ecosystem. A workspace is a collection of one or more packages, and these are called workspace members. And that collection of packages is managed together. And in a workspace, each package is going to define its own pyproject.toml file, but the entire workspace will share a single lock file. So that's another concept. If you're interested in another video on this, let me know in the comments as well. And we've also seen a little bit about managing Python versions. For example, when you initialize a project using 𝗵, you can pass the --python option to actually determine which version of Python to use in the given project. So that convenience is really cool. It's really important, I think, if you're developing new applications to be able to quickly run a command and get the latest version of Python downloaded for that particular project, for that particular environment. Now what I'm going to do in a follow-up video is I'm going to take the FastAPI application that we built here, and I call it an application. It's not the most interesting app. It's just a single endpoint that returns a bit of text. But what I'm going to do is show how to containerize that using Docker, and how to manage the project and manage the dependencies using 𝗵 inside the Docker container. So that's going to be a very short follow-up video that I want to do, but if you have any other ideas, let me know in the comments. As well as Docker, there are integration guides for 𝗵 when it comes to things like Jupyter Notebooks and GitHub Actions, and also things like pre-commit hooks. If you're interested in any of those, also let me know in the comments. But thanks for watching. This has been a first look at 𝗵 in Python. I'm going to do a video soon on Nano Django, which is a cool way to have a Django application in a single file, and that's going to use 𝗵 in that video. But I think I'm going to use 𝗵 a lot more going forward, just because it's so fast and it's so convenient to add and remove dependencies. So I think that's the way forward for me, but let me know in the comments what you think. And if you want to support the channel, check out the Ko-fi page that we have in the description, and thanks very much to everyone who's contributed to that. Thanks again for watching, and we'll see you in the next video.